Welcome guys. I'm gonna talk about today circle mill because I got a request from one of the subscribers. So I have a part over here. It's actually I got a bunch of pieces. Let me switch the video. So as you see, we got a piece that's like halfway done. And the reason this looks like this is because this is actually the part. Comes from here to here. And the clearance of my jaws wouldn't allow me to actually do this right here. So I have one on the machine. So as you see, if I had to have this piece and hold it over here, there's no way I could get to these holes. So what I had our saw guys do is cut me a much longer piece. So I'm gonna get two pieces out of here. So since this section is already done, what I'm gonna do is I'm gonna flip the part and then I'm gonna hold it by here. Alright, so imagine you're gonna reverse it. So this section will go here and I can get to this piece later, turn it, and also mill the holes over here. And I mill them using I'm gonna show you a circle mill. So circle mill technically is gonna be done on a Z and Y. So we're moving across Z, and the machine is gonna go up and down, and I'll show you in a second. So we're doing it Z and Y, and as you've seen, there's pretty much 8 holes. So just to kind of show you, so you got 2 holes over here, 2 holes, pretty much kind of all around here, the bottom and top. So all these holes are 90 degrees spaced apart. So you got first one circle mill position C0, second one 90, third one 180, then 270, and then we're going back to 0 because this is that shift that's going to be the first row and the second row. Okay, so we have a circle mill Z and Y position C. A type of this is gonna be there's a planet. Let me see what do you call it. So you have 2. One is circular and one is tornado. The circular does this. It starts smaller and then it just opens up the hole like this, right? The tornado, if you're gonna look from the side, it does this. It comes in deeper and deeper and deeper. So it just opens it up. So it hits the outside the walls, but it pretty much just kind of goes deeper and deeper. So that's the difference. The diameter of the holes is going to be 1.5 inches. How deep we're going to go? So it's 2.25 deep. Okay, that's going to be starting from your radius, which is the outside diameter. I got a 0 chamfer and bottom is gonna be 0. Now bottom, this is gonna be your finishes, and as you see on the bottom, ask you what type of finish you want. So 1 is gonna be roughest, 9 is gonna be a finer finish. And what that does technically, if I would show you, is that if you're going 0, the machine is gonna go, the end mill goes like this, it stops at the end and it pulls out. If you're gonna give it a finish, it's gonna go to the middle, it's gonna stop on the bottom, full depth, it's gonna do a full circle to clean up that bottom face, but as you see, there's no bottom material. This is actually true, right? But if you had a bottom and you want that bottom to be finished, this is what you use. And the reason, let's say if you have a 0 and you do have a bottom, you would have, let's say this is the bottom, it would kind of leave you this little step of the material, because like I said, it would come down this, it would hit the bottom and it would escape. versus if you have that finish 1, 2, 3, 4, 5, 6, 7, 9, it's gonna come down to that last cut. It will do the full circle, and then it's gonna come up. So this is where you put that finishes on the bottom. When you do thread milling, also the bottom is gonna be 0, and here are the depth of cuts. So technically about 100,000 pitch on pitch 1 and pitch 2. Then we have our end mill, which is I'm using 3/4. My hole, that's copied from here, 1.5. We are going 2 inches and 1/4 counterclockwise. This is the rough bottom face that it's actually gonna read. So since this doesn't matter, right? But technically, whatever you're gonna put over here, this is what the machine's actually gonna do. I got it as a 6, but I can put a 0. It's not gonna it doesn't matter in my case, right? Since I don't have actually a bottom material in the bottom, because I'm going all the way through. And then I have my surface speed 435, my feed rate is 7,200, and here is we're describing the material. So we're doing 1 point, but as you see on the bottom, you have a point. You can do it on arc, which I could have done too. You can do a line, a square, or a grid. So if you have a lot of them, for example, you know, this is what you're gonna play that with. Starting point Z, so that means 1.25. That 1.25, and this is my 0, is gonna be the center of this hole. Not the beginning, not the end, it's gonna be the center, okay? That's where you set your starting point Z. My starting point Y is gonna be 0, okay? And starting point R, it's 3.5 inches, so that means it's gonna be 7-inch diameter. And as you follow everything else, it's pretty much just repeating, right? Just my angle. So 0, C, 90, 180, 270. And then as you see, the second round, which is gonna be the second row, the only difference that's gonna be is starting point Z. Now we are 3 inches and 630 from the 0. Now after that, if you're gonna look at this part, and I got a little bit, let me put my glasses on. I have a little bit of glare from the light, but there's a chamfer, as you see, okay? So the chamfer, we're doing in a ZNC, right? So it's gonna go towards the length, and C, that means it's instead of coming down, up and down on a Y, it's actually gonna be rotating. This is inter AX and inter R. If you get an alarm for clearance, I usually put 1s over here, and that usually kind of it allows me to actually machine the size of the chamfer. You put over here, it's 40,000. I use my chamfer end mill, which is a 1/2 inch. Approaches are automatically populated counterclockwise. Width of the cut, I put it as 100,000, but technically you can put 200, it doesn't matter. My surface speed, my feed rate is 5,000. Now shift R, same thing, diameter. Half of the diameter, so it's 7 inches. Now P1Z, this is gonna be also the center of the hole from your 0 position, which is 1 inch and 250,000. And C is gonna be 0, as you see. Next one is gonna be 90, so on and so forth. The only difference is that P3ZR, instead of, as we put in 1.5 inches of the hole, this has to be actually a 3/4, because P3ZR, instead of when you're doing circle mill, that you actually have to give it a full circle size. On this chamfer, and I have no idea why it does it. It calculates from the middle to the side. Okay, so you give it a center, and it's gonna do 3/4 this way and 3/4 this way. I don't know why it does it, but if you try to put it 1.5 inch R, then technically it would go around 3 inches. So I'm gonna show you how it runs chamfer as a demonstration. So as you see, the chuck is rotating. Okay. And I'm gonna show you how it moves on a circle mill. So the circle mill, it does on a Z and Y, right? So you're gonna see the turret going up and down. It's spitting coolant. Now, if you look at the actually turret, let me see if I can show you. You're gonna see that it moves on a Z and then it just comes down. So your C is technically locked. So as you see, the C is 0, my Z is moving, my axes are moving, and your Y is also moving. So technically, like I said, this is how you program a circle mill. I'm going to take the picture of the program. So just remember, tornado 1, diameter is going to go diameter in the whole side. The depth is going to go here and here. Your bottoms, this is where it matters. So your bottom, if you have a hole through, you can put a 0, you can put a finish, whatever it is, it doesn't really matter. But if you do have a bottom, if the hole is not through and you want to have a nice finished bottom, put that BTM and roughing over here, a value of 7, 8, for example. These you don't care about your speeds and feeds, and like I said, the center of the hole from your 0 is here. Your Y is gonna be 0 unless you have like off center on a Y pull out, and SPTR. So this is gonna be diameter times 2. Chamfer mill, same thing. You follow, but this is gonna be Z and C. Inter AX and inter R. If you put 0, 0 and you're gonna try to run it, and you're gonna get a clearance alarm, try to input once. These usually solve the issue. That's the clearing moves on your inter AX and inter R. And I'm gonna show you. I'm gonna press 1 here. I'm gonna go to the question mark, and it gives you a clear drawing. So your inter AX, right? That's gonna be your height, and your inter R. These are your clearances on the side. Okay, and let me see, we're gonna shut this off. Kind of go back here. So I got one here. Chamfer size is gonna be that 40,000 counterclockwise. Width of your radius of the cut. So if you have a 1/2 inch end mill, then let's say, or chamfer, the minimum you have to put is about 250, but technically 100 works because I'm only using 40,000 out of it. And shift R, twice cut your diameter in half, center of the position, and P3ZR, that's gonna be half the diameter of the hole you're trying to chamfer. So 1.5 inch hole is gonna be 3/4. All right, guys. I made this short. Hopefully, this is gonna work out. And and thank you very much, and see you next time.